This demonstration is going through how to construct a confidence interval of the population proportion at a confidence interval that I'm going to use of 0.9. So I'm following the technology manual out of our textbook, but I want to do this example with x equals 30 and n equals 150. So the problem starts out with a confidence level of 0.9. So if I have a confidence level of 0.9, that's the area under our standard normal curve centered in the middle. So that means I have 0.1 left, right? 1 minus 0.9. Then to find the area in each tail separately, I'm going to divide that in half. So alpha divided by 2 is 1 minus the 0.9 divided by 2. So now what we want to know, so now we know that the area in an individual tail is 0.05. So the next thing that we want to do is we want to come up with the z-score that corresponds to that area. So we're going to use norm S inverse, so that's the function I'm going to use. So I'm going under here under the function tab, and I'm going to type in norm S inverse. Then I'm going to click on that function, and that function says, what's the probability? So the probability that I'm going to use is that 0.05, and I'll click OK. So negative 1.64485, on and on and on. So the issue with that is that's that area in the tail, and it's negative, but our critical value when we're using this formula, we'll use the positive value for that critical value. The next thing that I need is I need to calculate the error. So that's my next thing. I'm going to fix this so that I can get that to change to a positive. So I just put a negative out in front. So the next thing I'm going to do is I'm going to calculate the error. So I put the formula right next to it. So the formula that I'm wanting to load is the critical value, z alpha divided by 2, times the square root of p hat times 1 minus p hat all over n. So this is the equation that I'm trying to put in this cell. So the first thing that I need is I need p hat. So p hat is x divided by n. So we'll say equals 30 divided by 150. So there's our p hat. So now we'll come up here and we'll get ready to load that formula. So I'm going to call out the critical value, which is up here in row 5. And then I'm going to multiply that so I'm going to say equals, and I'm going to call out this column times the square root SQRT parenthesis p hat, so that was our value from down here, times 1 minus p hat parenthesis. So that's what's in the numerator. P hat times 1 minus p hat divided by n, which is 150. Close my parenthesis to close the function. Oh. And we're going to get 0.053721. So now our next thing is we're going to create the lower bound and the upper bound. So we'll take the value, and the formula for that is p hat minus the error, p hat plus the error. So equal p hat minus our error, and then for the next one down, p hat plus the error. So in this example, now we're going to say our confidence interval is between 0.146 and 0.254 if I round both of them to 3 decimal places. So our statement, so we're going to say I'm 90% confident that the population proportion is between 0.146 and 0.254.